has. Okay? The number of divisors. Or another way to say that would be the number of factors. Okay? So now let's go back here and let's look at the number 18. Okay? And I'm going to write down what we know are the number of factors for 18. So we've got 1 times 18, 2 times 9, 3 times 6. Okay? So we have 6 divisors or 6 factors of 18. All right, so if we can write prime factorization of 18 is 2 times 3 to the second. That's what we got when we were doing it earlier. So this is like 2 to the first power times 3 to the second power. Okay? So there's a theorem that says that the number of divisors of this number right here, which is another way of saying 18, is equal to n plus 1 times m plus 1. Okay, where n is equal to one exponent and m is equal to the other. Okay, so let's look at that. If n equals 1 and m equals 2, this is what we have. 1 plus 1, and m is 2, so we have 2 plus 1. So what we really have when we do our math using order of operations, we do parentheses first. So 1 plus 1 is 2, 2 plus 1 is 3, 2 times 3 is 6. Okay? So if we can write something as prime factors, we can multiply them together. Okay? Now, let's look at this. Let's look at 1040. All right, 1040 represented as 2 to the fourth power times 5 to the first power times 13 to the first. Okay, so here we have 3 of these. So we have an N and an M and a P, if we want to say that. So the number of divisors then would be 4 plus 1 times 1 plus 1 times 1 plus 1. Okay, 4 plus 1 is 5. 1 plus 1 is 2. 1 plus 1 is 2. And 5 times 2 is 10. 10 times 2 is 20. Does it work? Well, let's see. We have how many divisors here? This doesn't, remember, have anything to do with this. The 2, the 5, and the 13. What it has to do with is this is the number of factors of 1040. So if we started out and did 1 and 1040, now I do it this way because 1 is the smallest, 1040 is the largest. Okay, then I also have 2, and if I divided that by 2, I would have 520. Okay. Prime factors tell me that I can add divisibility tells me that I can sum my digits. 4 and 1 is 5. So I know 3 won't divide into it. Okay. The last 2 digits are divisible by 4, so I do know that 4 will divide into it. So when I divide this by 4, I get 260. Okay. Now it ends in 0. I'm sorry. So we know that it divides by 5. So 5 times what? Now here's the trick here. 13 times 2 to the 4th power would be 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 times 13 would be one of your factors. And you keep on going until we get to the middle. Okay, now that was a large number for us to pick up and begin, but you can keep going with these and you should have 20 factors when you finish. Let's look at the number 24. I always like to do 24. It's got a nice set of factors, okay, and it's easy to see. 1 and 24, because remember we can never have any factors larger than 24 because that's the number itself. Now, divisibility, it's an even number, so it divides by 2. So 2 times 12. Okay? 3, sum of the digits. 4 plus 2 is 6. 6 divides by 3, so that 24 divides by 3. So 3 times 8 is 24. Okay? 4 times 6 is 24. Now, notice right here, you've got 4 numbers down here, 4 numbers up here. Alright, when we look in here, the only thing that could be in the middle is 5. And 5 won't divide into 24 because it doesn't end in 5 or 0. So we're finished. So keep in mind that once you work close together here, then you can look and say, I've exhausted my whole list of numbers that could be possibilities by starting with 1 and working up and eliminating. Okay? And it works that way every time. That way you don't leave out any factors. Okay? Another rule that we know when we talk about divisibility is that if we have a number D that is a divisor of N, okay, then we know that N divided by D is also a divisor of N. Okay, so let's do that as an example. All right, let's say we know 3 is a divisor of 24. Okay, so this is our D, this is our N. So then I know, according to this theorem, that N, or 24, divided by D, or 3, which is 8, is also a divisor of 24. Now, that makes sense because if we take our number that we start out with, 24, and we know that this is a factor of it or a divisor of it, they're the same thing. They just look at the different way. Divisor you think about in terms of division, factor you think of it in terms of multiplication. So if 3 is a divisor, then that also means it's a factor. So the other number that I get when I actually divide it would be my other factor. So we know that it's also going to be a divisor of the original number itself. And that's it for the theorems that we have in this homework.